Welcome to this comprehensive tutorial on using the Eclipse Memory Analyzer tool, often abbreviated as MAT. In this video, we'll explore how to analyze memory leaks in Java applications, understand object retention, and optimize memory usage. Let's get started. First, we need to understand what the Eclipse Memory Analyzer tool is. MAT is a powerful tool that helps detect memory leaks and reduce memory consumption in Java applications. It provides detailed insights into what's consuming memory in your application, allowing you to identify memory leaks with ease. To start using MAT, we need to download and install it. You can find the latest version of MAT on the Eclipse website. Ensure that you choose the correct version compatible with your operating system. Next, let's install MAT. After downloading, extract the zip file to a desired location on your machine. Of course, if you're using an IDE like Eclipse, you can also install MAT as a plugin directly from the Eclipse marketplace. Now that we have MAT installed, let's create a simple Java application that will intentionally generate memory leaks. Open your favorite IDE and create a new Java project. In this example, we create a list that indefinitely adds new strings to itself, causing a memory leak. Run this program, and you will see that it starts consuming memory rapidly. After a short time, it will cause your JVM to throw an out-of-memory error. Stop the application to generate a heap dump. Once we have the application running and consuming memory, we want to create a heap dump. You can do this by setting JVM options or using the jmap command on your running application. Here's how to use jmap from the command line. Replace PID with the process ID of your Java application. After running this command, you'll see a file named heapdump.prof created in your working directory, which we'll analyze using MAT. Now let's open MAT. You can do that by navigating to the directory where you extracted MAT and running the MAT executable. In the initial screen, select File, and then choose Open Heap Dump to open the heap file we generated. Upon opening the heap dump, MAT will take a moment to analyze it. Once it's finished, you will be presented with the initial report screen. In this overview, you will see various metrics such as total memory used, classes count, and the total number of objects. Let's dive deeper into the report. In the left-hand menu, there's a section titled Leak Suspects. This section highlights the potential memory leaks detected in your application. Click on it to see a list of suspects. Here, you will see the most significant suspects of memory leaks along with their retained size. Select a suspect to examine its object details. MAT provides several metrics, including the number of instances and their retained memory size, which are critical for identifying which objects leak memory. By clicking on problematic objects listed, you can explore their path to root. The path to root feature shows how the object is being retained in memory, which can help understand how and why it wasn't garbage collected. In our example, we will likely find the list holding references to string objects causing the memory leak. Observing the path helps us realize that we're unintentionally keeping references in the static list. Another handy feature of MAT is the histogram view. This view displays how many instances of each class are in memory and their total size. You can find the histogram by clicking on the icon in the toolbar. In the histogram, you can sort the classes by their size or instance count to quickly identify large objects or those with a high count. This can lead you straight to potential memory-related issues. Apart from analyzing leaked objects, MAT allows you to explore the dominators tree. This feature shows how objects are related and which ones are dominating memory usage. The dominators view can help you find out which object is retaining others, ultimately leading to memory bloat. Now that we have identified the objects retaining unnecessary memory, it's time to fix our code. Go back to your Java application and implement a fix by clearing the list or avoiding the static reference. Here's a potential fix you could try. After fixing the code, I recommend rerunning your application and generating a heap dump again using the same method we discussed earlier. This will help you verify if the memory leak has indeed been resolved. After reanalyzing with MAT, you should see that the previously highlighted leak is no longer present or has significantly improved in memory usage. This process of analyzing, identifying, and fixing memory leaks can greatly optimize your application's performance. As a final tip, remember to use MAT regularly as part of your development process, especially in large applications or during heavy refactoring. Incorporating MAT into your workflow will not only help catch memory leaks early, but also maintain the overall health of your Java applications. This concludes our in-depth tutorial on the Eclipse Memory Analyzer tool. If you found this video helpful, please give it a thumbs up and share it with fellow developers. Subscribe for more Java programming tutorials, and don't forget to click the bell icon for notifications on our latest uploads.